Version 2 of the NZXT H1 has arrived. If you don't remember the version 1 of the NZXT H1, we'll remind you. There it is. You have a good shot of that?
Yes.
Okay. So that problem is supposed to be solved with this one. NZXT attempted varying solutions for the NZXT H1 riser cable fires issue. It went from sort of talking about it to launching some clear plastic screws that didn't fix the problem, but could maybe work around it if you actually got them. And it later, after much pressure and pressure from the US CPSC, which is a protection agency, went to redesigning the riser cable, then shipping a different version of it anyway. We've arrived here with the NZXT H1 V2 that we're reviewing today. Clearly this is NZXT's attempt to clear its name, fix the problems, and move on from the original H1. And we're going to be looking at the riser cable in this one to see if it's resolved, in addition to actually reviewing the case itself. Before that, this video is brought to you by Lexar's Professional Series 2000X SD cards. We've actually been using this exact model of SD card internally for at least 4 years now, having bought them ourselves, and whenever we buy new SD cards, we typically buy this exact model. We're happy to advertise this particular one since they've traveled all over the world with us and have filmed thousands of hours of footage. Lexar also has a new 3-in-1 card reader that you should check out for your media projects. Learn more at the link in the description below. So first off, the way we're looking at this, NZXT's handling of the original H1 issue was extremely bad. Communication was pretty bad. We'd gotten ignored originally when we emailed about the problem, and it wasn't until we went through the CEO that we got some attention for it. And so the handling was terrible. It was the opposite of what Fractal did with its torrent, where it got out ahead of everything and said, sorry, this is hazardous, and it recalled them all and then shipped fixes. So that's number one. Now, with that said, if NZXT has resolved the issue this time with the H1 V2, at least as far as we can tell with a single test sample, we're happy to more or less put this behind us. We won't forget it, obviously, but the thing is, when we look at what a company has done, just like with the Newegg stuff, we do want to give the company a chance to fix the problems and improve. Because as we said with the Fractal scenario, every company is going to make mistakes because there are so many links in the chain. This isn't some hand-wavy like, oh, everybody, kumbaya, whatever. It's the reality of global manufacturing, where there's so many different companies involved in making the product that something will slip through the cracks for everybody. And as long as it's fixed and it doesn't kill anyone, that's fine. NZXT had that potential with the H1. That's why we were so upset with their handling of it, because fire, it's kind of a bad thing. But this, if it fixes it, we're happy to tell everyone that, as far as we can tell at least, it's been resolved, if it is in fact resolved, which you're going to find out today. And then hopefully NZXT can kind of move forward and act a little bit better for the next one. All right, so all of that said, stuff you're going to need to know today. The riser cable, obviously, we're looking at mostly to see if we can clear it from the past issues. There is an included pump and block as well, included AIO or CLC, and there's also an included power supply. Now, the power supply was sort of problematic for us, but it's actually not NZXT's fault in this one. The power supply is problematic because of transient loads on the modern GPUs. We're going to talk about that a little bit later, but suffice to say, choosing a super high-end card with this box could potentially cause problems for you, and it's because of how NVIDIA has decided to handle transient loads and push it all onto the power supply manufacturers, which is a problem when it's an SFX power supply with limited real estate to work with. Anyway, more on that later. So as for what this is, the H1 V2 is a tall Mini-ITX case with the same general form factor as an Xbox Series X or a Corsair One. NZXT sells it as both a pre-assembled system through NZXT Build or as a case with a pre-installed PSU and AIO CPU liquid cooler. The V2 differs in more ways than just the riser cable. It's a different case, it's been retooled. And as a standalone case, standalone here in sort of air quotes, the H1 is priced at $400 in the US. That would be very high if it were just the case, but again, it does include the power supply and the cooler. Still pretty high for the pricing, but it's Mini-ITX, so you pay a Mini-ITX tax. Now, as we get into this, quick reminder, we don't focus on Mini-ITX case reviews in our case review suite. We typically do ATX. The reasoning for this primarily comes down to standardizing for Mini-ITX is extremely hard, and it's hard to do it in a fair way that's representative because they all fit such different size components that if you standardize for one type, it's invariably your test system will not fit in another one, or it'll be too small, like in something like this, it's a little bit larger and it just doesn't represent things. So we test this basically against itself in the thermal section, which is still very useful and tells us a lot about design. It's just there's not comparative data for our Mini-ITX test because of the nature of controlling for that variable becoming a little bit too unrealistic. Enough of that. Let's start with the riser cable discussion and go through our testing process for the new PCIe Gen 4 cable. With that said, our testing of the V2's riser cable indicates that it's unlikely to suffer from the same problems. We asked NZXT to share some schematics with us, and it eventually convinced its supplier to do so, and you can see those here. The through holes are all plated, and none of them are connected to 12 volts or ground. The two screwed down sections of the PCB are intentionally isolated by gaps. We've tested for other functional riser cables that ground their plated through holes, which has its own advantages. But clearly NZXT wanted to take zero chances with creating a short circuit on this one. Scratching the protective coating on either side of the PCB revealed no power or ground planes, and even putting a massively oversized self-tapping screw through the holes didn't create a short. And this, by the way, is completely unrealistic and not something you should do, but it is a large part of what caused the problem in the original. If you had forgotten, that's how NZXT was shipping it. The reason it doesn't create a short this time is because the sides of the PCB are isolated and contain no 12-volt circuitry. There are ground planes around the through holes, as shown in the schematic, but they're buried too deeply to be easily exposed and are separated from the true ground plane. NZXT's supplier has also specified a minimum distance of 0.246 millimeters between 12 volts and ground traces on the male end and 0.175 millimeters on the female end, which it claims is enough to avoid any risk of shorting due to manufacturing variants. This is what we want to see, and at least for our units here, we would qualify these as good and passing, and we are not able to create the same fire hazard issues with these that we saw with the original ones with the H1. So, at least based on this sample, NZXT has fixed its problem in a satisfactory way. Time to talk about build quality. Starting with the exterior, the new NZXT H1 now has two USB Gen 3.2 Type A ports on top of the case. This is a departure from NZXT's cases for the past few years, which generally have, in this order, one power button, no reset, one USB Type A port, one USB Type C port, and one combined audio jack. That's a visual design choice that we've previously classified as, quote, asinine, and it's not one we've ever agreed with. So we're happy to see a second Type A port make a return on the new NZXT H1. That's an improvement. It's especially relevant on an H1 style case anyway, because all of the onboard I/O is hidden and inaccessible, and you don't get as much of it with a Mini-ITX board, so this does matter here. For example, we called the Height Revolt 3's I/O, quote, usable but sparse, with exactly the same number and type of connectors as on the H1 V2. On that subject, we're still not fans of arranging the case with I/O on the bottom in general, but we recognize that it's a stylistic choice. We repeatedly had problems with HDMI connectors pulling out of the GPU as we moved the case across surfaces, so there's still some stuff that could be improved. The V2 is slightly bigger than the V1 in every dimension. It's 17.3 millimeters taller, it's 8.4 millimeters wider and deeper, and this leads to greater GPU compatibility. We were able to jam EVGA 30 series FTW3 cards in without too much trouble, and those are very fat cards. And we used an ROG Strix 3070 Gaming for our thermal testing, which is nearly exactly at the maximum 58 millimeters thickness and 324 millimeters length. Thickness is the more dubious of the two claims dimensions. GPUs that have screws or other small projections may snag on the reinforcements of the nylon side filter as the case sides are being slotted on. Even if the GPU is technically within the size limit, you can still run into these problems. Still, we managed to get the Strix in. Returning to the exterior, we need to address some airflow points that we've seen in comments online. The pattern of the ventilation holes has changed this time. On the original H1, we measured a hole diameter of 3.4 millimeters with 1.7 millimeters spacing, which is a 34.9% ratio of open air to metal. On the V2, we measured a hole diameter of 4.9 millimeters, still with 1.7 millimeters spacing, which is a 43.3% ratio of open air to metal. These are both percentages on a finite scale from 0 of solid metal to 100 for open air. So we can compare the two with very simple arithmetic. NZXT cut away a further, or an additional, 8.4% on top of what was already cut away of the panel surface. So that's an improvement. Now granted, the size of the panels and the margins of the ventilated areas have changed as well. and the case is obviously a bit bigger. However, overall, we are confident in saying that the V2 has improved access to air. In our experience, small form factor cases that are easy to work with are easy to work with because they aren't actually small, or not truly small. Like the O11 Mini, for example, it's Mini-ITX, but it's a pretty big Mini-ITX case, and that makes it easy to work with. There are exceptions, but the H1 isn't one of them. To its credit, NZXT has tried to ease small form factor annoyances by pre-routing and tying down as many cables as possible, and by printing detailed instructions and labels on every possible surface. We found that pre-routing for the power cable extension and the EPS 12-volt cable worked perfectly with our motherboard, but connectors with less predictable placements, like USB headers and front panel connections, were left loose and were therefore just as tricky to get in as ever. The side of the motherboard with the 24-pin ATX power connector was the hardest to work with, as even with all the side panels removed, it's still partially enclosed by the power supply. We didn't have any problems with component clearance, at least, despite making no attempt to pick out a small GPU or low-profile RAM, so that's good to see too. The labeling was helpful in getting the case disassembled and installing the CPU cooler correctly, but it had a direct negative consequence. When we turned the system on for the first time, one of the wordy tags on the CLC immediately got caught in a fan. The riser cable is stretched around the rear of the motherboard tray with no slack, so you may want to unscrew it from its mount before inserting it into the PCIe slot. And then you'd have to screw it back down, obviously. Temporarily removing the riser cable also makes it easier to access the rear of the CPU socket for cooler mounting. The cable is also now PCIe Gen 4. Updating the PCIe generation alone would have been enough for a silent revision, but we're happy to see that NZXT took the opportunity to make other improvements. The closed-loop liquid cooler that NZXT included with the H1 V2 is an RL-KR14H-01. The closest standalone cooler that NZXT currently sells is probably the Kraken 120, at least in sizing for the radiator. The H1's variant is more compact and has short tubes. This is specifically intended to fold down into the body of the H1. We'll talk about thermals in a moment, but we don't have any strong complaints against this CLC that weren't already covered in our Kraken M22 review 4 years ago. This is probably the most legitimate use case for a pump and rad design outside of patent dodging, and it's also the most legitimate use case for a 120mm CLC, because outside of a really small case, they offer no value over a cheap air cooler. This is sort of the cutoff point where liquid coolers really lose any benefit that they would offer, which is all primarily at the larger sizes. In a small case, though, where you're limited on, obviously, space, it makes more sense. Pre-installing the radiator on a hinged door makes it a lot easier to work with than similarly sized cases, including the Revolt 3, and small touches like the captive screws on the radiator tray are much appreciated in the H1 V2. Special care still needs to be taken to avoid crushing the tubes or letting cable snag on the fan blades, but it works fine. Our G-Skill Trident Z RGB DDR4 sticks were at the absolute edge of what could fit underneath that radiator, with a total height of 43 millimeters, including the pins. As for mounting compatibility with CPUs, NZXT is launching the V2 with LGA 1700 hardware, but the current selection of ITX LGA 1700 boards is pretty limited. Now for one of our other enemies of NZXT's solution suite, NZXT CAM. We've complained at length about NZXT's CAM software and its smart devices that require it. The H1 V2 is afflicted with one of these, they don't deserve to be called smart devices, but it's afflicted with one of the smart devices. At least it's only responsible for two things though, the CPU fan and the case fan. It monitors the pump as well, but it runs at 100% speed, which we agree with. The physical shell of the smart device is used to clamp down and manage power supply cables, which it does well despite not being screwed into place. And as for the rest of the smart device, if you don't remember why we found them pointless, it's because they didn't even do some of the advertised features like noise control adaptively. And most of the other stuff just didn't really work. Anyway, the side of the H1 behind the motherboard tray is pure GPU intake, and the other two sides are a combination of exhaust and intake. This means that none of the 3 nylon filters on the side panels can be easily gotten rid of. Exhaust doesn't need filtration, but intake does. Swapping the glass panel with a mesh one would obviously allow even more airflow, but NZXT stated the following, quote, "We believe that the improved cooling performance of the newest revision to the H1 provides adequate cooling for each component, which lessens the need for a mesh front panel. However, we'll need to monitor community feedback and market trends in the small form factor cases to make a determination for the future. It might be fine. The V2 has added a 92mm exhaust fan to the opposite side of the case that should assist standard GPU coolers, which could help make up for the other side of the GPU being encased in glass. We'll see in the thermal section coming up. For thermal testing, just for this one-off piece, we used a stock i9-10900K, an Asus RTX Strix 3070 Gaming, two 8GB sticks of DDR4 3200 Trident ZRGB, and an MSI MEGZ 490i Unify motherboard. The stock thermal paste on the NZXT cooler was kept for testing since it's included with the case. We initially tried to use an RTX 3080, a known good unit, but we experienced a lot of power problems. The V2 for the H1 contains a 750 watt power supply, up from the 650 watt power supply in the V1. On paper, this is more than enough to support the highest end hardware, including the 3080. In practice, however, we saw the actuality of transient load with the 30 series. When we started the full system torture workloads, the system consistently shut down after less than a second of load. Thorough testing of the power supply on our load equipment revealed no anomalies other than unusually high OCP allowances on the minor rails, so 5 volt and 3.3 volts. 12 volt protections were entirely normal. The only definite problem was the metal housing of the power supply, which is so flimsy that taking it out of the case caved in the protective grill. After more research, we concluded that the transient load spikes caused by the RTX 3080 in conjunction with the CPU power draw was enough to cause the shutdown. This is a problem particularly for SFX power supplies because they rarely have the capacitance to hold up to transient spikes. You might get some 3080 combinations with this power supply that would work fine, but others won't, like the one we chose, and there's not any way around that. You just need a different power supply, and there aren't many SFX power supplies that can withstand a transient spike as experienced on the 30 series. Our conclusion is that using a 3080 or a 3090 on this power supply is probably overambitious. Even though it's technically supported, you're rolling the dice on whether it'll work well. And to be clear, that's because of NVIDIA's spiky power behavior on the 30 series. It's not really a shortcoming of NZXT's power supply, it's a factor of the limitations of a small form factor power supply. So as we said earlier, we don't have a current database of ITX case test results to compare against, and we don't plan to build one just because ITX is so highly variable. It makes a lot less sense to control in that way than ATX. Instead, we did some simple one-off tests to compare the H1 against itself in various scenarios, and this still allows us to evaluate the thermal design of the case. Unlike our typical case tests, we didn't initially control for CPU clocks or GPU fan speeds, but we'll be able to demonstrate the differences in those as a result of thermals as well. We'll start with CPU thermals under a full torture workload on the CPU and GPU. The case fan and the radiator fan are both set to 100% speed. After running the load long enough for temperatures to reach steady state, the average is 47 degrees Celsius above ambient. That's about 67 degrees without subtracting the ambient temperature, still below the 70°C cutoff for thermal velocity boost, by the way. Removing the two discrete side panels, that'd be the glass and the mesh panel on the opposite side, lowered the load temperature average to 42 degrees Celsius, again, above ambient. So that's 5 degrees of improvement, which would be impressive in some contexts, but the fact that we removed two sides of the case, including a full glass panel, and only dropped average CPU temperature by 5 degrees, is an indicator that the side panels don't completely kill airflow to begin with. Because the CPU was below throttling temperature and even below the TBB cutoff temperature throughout torture testing, there was effectively zero difference in clock behavior with the panels on or off. As the all-core workload began, CPU frequency dropped to 4.9 GHz, which is expected. Then, as the power limit expired, it dropped again down to 4.2 to 4.3 GHz for the remainder of the test period. All of this looked normal, and it was unchanged between the two types of tests. GPU temperatures were unchanged with the removal of the side panel from the baseline result of 39 degrees above ambient. That's partly because we allowed the GPU freedom to adjust fan speeds, and it adjusted its fans to maintain a constant temperature just under 60 degrees. This is why we regularly point out that GPU temperature isn't like a 3D Mark score. It has a V-BIOS where it follows a certain behavior for the fan ramp versus the temperature target. So we have to check the fan speeds, and those averaged 1510 RPM during the baseline torture test and 1417 during the test with two panels removed, as they could spin slower while maintaining the same temperature. It's not a huge difference ultimately, but it does demonstrate one important fact. There are other variables at play than just thermals. So running a hotter card than we have here would result in potentially a higher noise level to compensate for the various hotter configurations of the case. If we were to standardize for Mini-ITX reviews, we'd control for all of these behaviors, but since this is just intended to be a one-off, it's actually more useful to look at the RPM change more directly since it shows the realistic result of what you can expect. There was some natural hysteresis in GPU fan speeds over the course of testing, but speeds were consistently higher throughout the test with the panels on. Given the lack of variation in temperature and relatively small variation in GPU fan speed with the panels removed, it mostly looks like NZXT's side panel doesn't overly obstruct airflow on the GPU side. We installed a beta version of CAM with support for the H1 V2 and dug around in the profiles. The per fan options are silent, performance, fixed, and custom. Selecting a preset profile allows examining the thresholds and modifying them, and by default, the performance profile ramps linearly from 50% with the CPU at or below 55 degrees Celsius, up to 100% with the CPU at or above 60 degrees Celsius. The silent profile isn't quite linear, but instead curves from 25% at or below 45 C, up to 100% at or above 60 degrees C. This means that based on the temperatures we observed in our baseline test, steady state behavior in both silent and performance modes should be exactly the same as baseline, with all fans running at 100% speed. That's exactly what we observed. With the full system load pushing the average CPU temperature above the 60-degree threshold for maxing out the fans as we saw in our earlier tests, the thermal results for both the CPU and the GPU are identical to the baseline results. The real test is how CAM and the smart device affect noise levels. At idle, with none of the GPU fans spinning, we measured CAM's silent mode at 31.5 dBA. Performance mode was at 34.1 dBA, and this is all in identical, exactly the same test conditions. And that 100% fixed fan speed test had us at 46.9, a massive increase, but an expected one. Because the system was idle, silent mode was running the fans at 25% speed, and performance was running them at 50% speed. With a full system load and the GPU fans active and thermals at steady state, we measured a noise level, obviously factoring in the GPU, of 47.3 dBA, which applies to all performance profiles since they act identically at the given CPU temperature. All of the stock CAM profiles scale up to 100% fan speed and err on the side of caution with CPU thermals, but we'd still much rather connect the fans and pump directly to the motherboard and set fan curves without having to install software. This is still possible, of course, but it feels a little wasteful since the smart device is included in the cost of the case. So wrapping all this up, first of all, as a case, neither the H1 or the H1 V2 cases are cases that really suit us, generally speaking, and that's fine. The H1 would never have been on our radar at all if it weren't for the fire fiasco that happened previously and the customer service fiasco that followed the fire fiasco. I don't know what the plural of fiascos is. It's a fiasco. Anyway, many fiascon behind us now. The H1 is for someone who thinks the Xbox Series X looks cool and wants a powerful gaming PC in the smallest possible footprint. There are smaller cases, of course, but this one fits pretty powerful components and basically the largest GPUs. Thermal performance is fairly good for the case's size and shape, but by buying the H1, you're also buying NZXT's power supply and liquid cooler, if not an entire pre-built system. Now, of course, one of our biases here on the channel is that we prefer the elbow room to choose all the components. And so for us, the appeal of having a power supply and liquid cooler included is not really there, but we understand why they did it, and we also understand why some of you would prefer that. One of the reasons you might like it is that it certainly simplifies selecting compatible components, and it also includes some pre-wiring of things like the power supply cables and pre-routing of the tubes and shorter tubes specifically for a Mini-ITX box. So those are all potentially positives. $400 though makes it expensive, and that's where selecting your own parts would get you in a little bit cheaper if you just chose the case and then bought two other things separately, or maybe you can bring your own. The biggest warning we have with this is, again, it's not actually NZXT's fault this time. This is an NVIDIA issue mostly, sometimes mostly NVIDIA though, where the power supply does not appear to have the capacitance to survive those bursty transient loads where you're looking at like maybe 100 microseconds or something of an extreme spike in power consumption on something like a 3080 or a 3090. We didn't have issues with the 3070 we tested. We ran the power supply through our power supply load tester, and overall it seems like it's more of an issue that's isolated to potentially very high-end, like 3080, 90 types of GPUs, plus high-end CPU under a sudden instantaneous 100% load, or if it's not doing that, then it's fine. And so this is, again, an NVIDIA issue, but the takeaway we think is probably pick sort of a 3070 and below if you're planning a 3080. it might be fine. It might also have issues where you get a sudden shutdown with transient spikes, and there's not really much you can do to verify before you buy everything if that's going to happen to you or not. And it's going to vary a little bit from card to card too, because they all have a different vBIOS power profile. And this is also not something that NZXT can easily solve in an SFX power supply form factor. In ATX, it's much easier, and it would start to become their fault. But in SFX, you lose the footprint that allows for soaking those transient spikes. It's possible, but it becomes significantly more expensive. For other cases, you might be interested in the Lianli 011 Air mini cases. They're pretty large. It's not that much larger than this, but it is definitely larger. The Fractal Torrent Nano is also large, but those are ones where if you're interested in Mini-ITX, but you don't want the pain in the ass it is to build in a true Mini-ITX box, that's where we would maybe steer you. For those who liked the H1, but were maybe turned off by the potential of it catching on fire, this seems like a fine upgrade. We were not able to get the same issues to appear in this one. Like we said earlier in the review, it is hard to prove a negative, but our PCIe riser cable in this one is fine. And so, at least from that aspect, currently we have no reason to suspect that the NZXT H1 V2 would have the same issues as the V1. So that's good. It looks like NZXT has fixed the issue. So at this point, as long as it stays fixed, we're sort of willing to mostly move on, leave it behind us. Obviously, as long as NZXT keeps it up. If the company improves and fixes the problems that caused the mess to begin with, that's really all you can ask of it. Yeah, better handling would have been nice, but we'll look for that going forward. So NZXT for this one has passed our testing for that, and then the case itself, it really comes down to subjective opinion. We'll let you decide, but thermally it seems fine to good depending on what configuration you use it in, and the rest just comes down to size preferences with Mini-ITX. So that's it for this one. Thanks for watching. As always, subscribe for more. Go to store.gamersnexus.net to help us out directly, or patreon.com/gamersnexus for some bonus videos. We'll see you all next time.